Good afternoon, everybody. First of all, just tell me if my voice is audible and my screen is visible to you or not. Just a small check. All right, very good. Very good. There's somebody who did not, who is not able to listen me. Please check it again. Rest everybody is okay. That means my voice is audible and my screen is also visible to you guys. So today, like for the last 4 to 5 classes, we have been doing limits, continuity, differentiability, and their questions we have also done. Today we will do some concepts of determinants and matrices, and I'll try to do things which you have not yet covered in your syllabus. All right, like addition of matrices, product of matrices, determinants. You all are aware of that fact. What are they? So we'll do something new out of it. Got it? These questions we'll do later on. First of all, let me cover what I wanted to actually. Yes. System of linear equations. We'll start with this. Say we have a system. Say we have a system of linear equation in 3 variables. So a1x plus b1y plus c1z equals to d1. Then we have a2x plus b2y plus c2z equals to d2. And then we have a3x plus b3y plus c3z equals to d3. All right, a1x plus b1y plus c1z equals to d1. The method I'm going to tell you is called the Cramer rule. All right. Now see, if we solve these equations, values of x, y, z that we achieve is x is equals to d1 upon d, y is equals to d2 upon d, and z equals to d3 upon d. Where d is what? D is the determinant made with the coefficients of x, y, z. That is a1, b1, c1, a2, b2, c2, a3, b3, c3. D1 is what? Determinant, where first column is replaced by small d1, d2, d3. So d1, d2, d3, b1, b2, b3, and c1, c2, c3. Similarly, d2 is what? Now replace b, column of the coefficient of b, a1, a2, a3. Replace b by d1, d2, d3, and then c1, c2, c3. And finally, your d3 will be a1, a2, a3, b1, b2, b3, d1, d2, d3. So this is how we obtain the solutions of these equations. Got it? Now see, if equations are solvable, it is fine. You just find the values of d, d1, d2, d3, and you get the answer. Now say we have a system of equations. Now this system, now I will tell you about the system. This system is called consistent or inconsistent. This system is called consistent system or inconsistent system. Am I correct? Now, consistent means at least one solution. At least one solution. Inconsistent means no solution. Got it? Now, at least one again covered two varieties, exactly one solution. Now, later on, with respect to time, while your syllabus proceed, you will be done with 3D. Then in 3D, you will get to know that these are the equation of three planes. These are the equation of three planes. Now, three planes, if I see about their intersection pattern, so what happens? Either they intersect at one unique point, or they will have a line of intersection, means directly having infinite solutions. There is no possibility that they are having two solutions, they are having three solutions. So, exactly one solution. Now, if you see, if this D has a non-zero finite value, if this D has a non-zero finite value, we will get the values of x, y, z, and the system exactly one solution means D should be non-zero. The denominator of x, y, z, that is d1 upon d, x was what? X is d1 upon d, y is what? d2 upon d, and z is what? d3 upon d. So if this d is non-zero, we will say the system will have a unique solution. Got it? Now, for infinite solution, this d should be 0 as well as d1 is 0, d2 is 0, and d3 is 0. Got it? So, for infinite solution, d0 as well as d1, d2, d3 all are 0. And the inconsistent system means d0 and at least one of d1 or d2 or d3 is non-zero. All right. I hope I have made my point clear. Now you have to remember this. Got it? Got it. So D0 and at least one of D1, D2, D3 is non-zero. Everybody, please mute yourself. KNV Bhavnagar, please mute yourself. Got it? So again, I repeat, exactly one solution or a unique solution. D should be non-zero. For infinite solutions, D0 as well as D1, D2, D3 all are 0. And for inconsistent system means no solution, D0 and at least one of D1, D2, D3 is non-zero. Got it? Now there is one more thing we call, that is there's one more thing what we call trivial solution. Trivial solution. Now, what is this trivial solution? When 0, 0, 0 is a solution, 0, 0, 0 is a solution, we call it trivial solution. When 0, 0, 0 is a solution, we call it trivial solution. Now, what happens sometimes in few questions, they ask like a1x plus b1y plus c1z equals to 0, a2x plus b2y plus c2z equals to 0, and a3x plus b3y plus c3z equals to 0. Now see, these are three equations. Got it? Now, right side, there is already 0. That means origin is already a solution. If you check, all these three equations are passing through 0, 0, 0. That means if they are passing through 0, 0, 0, so origin is already a solution. That means this system is having trivial solution. Now what they are saying, in the question they are saying, given that the system is having non-trivial solutions. Now, if the system is having non-trivial solution, that means trivial solution it is very much visible. 0, 0 is satisfying all three equations. Now they are saying system is having non-trivial solution. Non-trivial solution means system is having non-zero solutions also. Means system is having more than one solution, means directly the system is having infinite number of solutions. Am I clear? So if the system is having infinite number of solutions, that means its D will also be 0. That means determinant A1, B1, C1, A2, B2, C2, A3, B3, C3 will also be 0. Am I clear? So this is very important. Most of the questions are asked from this particular concept only. That they are saying system is having non-trivial solution, and it's quite visible that system is having trivial solution. That means system will be having infinite number of solutions. So you just need to make D 0. So A1, B1, C1, A2, B2, C2, A3, B3, C3 will be 0. Got it? Just absorb it quickly. Now see a question. If the system of linear equations x plus ky plus 3z equal to 0, 3x plus ky minus 2z equal to 0, and 2x plus 4y minus 3z equal to 0. All right, they are saying this system is having non-zero solution. Now see, all the three equations, they are already being satisfied by 0, 0, 0. If it is so, that means the system is already having trivial solution. Now they are saying system is having non-trivial solution also. That means its D will be 0. So doing D 0 means 1, K, 3, 3, K minus 2, 2, 4 minus 3. This is going to be 0. Got it? Now without doing much efforts, you just start expanding and solve it. You get one time minus 3k plus 8 minus k times minus 9 plus 4 plus 3 times 12 minus 2k equals to 0. I just expanded along the first column. All right. So now it is minus 3k plus 8 minus plus k plus 36 minus 6k equals to 0. So 6 and 3, 9 minus of 8k is minus 44. K comes what? 11 upon 2. K is 11 upon 2. Am I clear? So it is minus 3k plus 8. Okay, sorry. It should not be this. It will be minus plus 5k. So 5 minus 6, it will be minus of 4k. So your k will be 11. Got it? Now see, from the first equation, now they're asking for the value of xz upon y square. Yes or no? So what do I do? From the first equation, I divide by y. So it will become x upon y plus thrice of z upon y will be minus k, which is minus 11. One relation you got. Now divide the second equation also by y. So 3x upon y minus 2z upon y is equals to again what? Minus 11. Got it? Now from these two equations, find the value of x upon y, then find the value of z upon y, then multiply them, you will get your answer. Got it? So this is how we approach. Now, this much is enough. Now you practice more question over this concept, d, d1, d2, d3. Got it? Now I will cover certain things and properties about the adjoint of a matrix. Adjoint of a matrix. Now, I hope you all are already aware what is an adjoint. Got it? Say you have a matrix A. Its entries are A11, A12, A13, A21, A22, A23, A31, A32, A33. You have a matrix this. Now, what do you do? Find cofactors of all the elements. Got it? Now in the next step, make a matrix C. Make a matrix C whose entries are the cofactors of, make a matrix C whose entries are the cofactors of the elements of A. So now you made a matrix C, that is C11, C12, C13, C21, C22, C23, C31, C32, C33. Simple cheese. I made a matrix whose entries are the cofactors of the respective elements of matrix A. Now take transpose of A. Sorry, take transpose of C. So that C transpose is actually the adjoint of matrix A. So it is represented by adjoint A, that is C transpose, that is A11, A12, A1, sorry. C transpose we have to do. So that is C11, C12, C13, C21, C22, C23, C31, C32, C3. So this is how we find the adjoint of a matrix. All right. Now, what is the speciality of this adjoint? Let you multiply a matrix A with its adjoint. So A is what? A11, A12, A13, A21, A22, A23, A31, A32, A33. Multiplied by its adjoint, that is C11, C12, C13, C21, C22, C23, C31, C32, C33. Got it? Now, if in the product, what will happen? Elements of first row and cofactors of first column. Got it? Basically, these are the cofactors of first row. They are here because you have taken the transpose of C. So elements of first row are multiplied by the cofactors of first row and added. What do you get? Value of the determinant. Determinant A. Now, elements of first row multiplied by cofactors of second row. So if elements of any row be multiplied by the respective cofactors of any other row and then added, the value becomes 0. Now, elements of first row and cofactors of third row, product will be 0. Elements of second row, cofactors of first row, value is 0. Here it will be determinant A 0, then 0, 0 determinant of A. So A into adjoint A is this. Now if I take determinant both sides, determinant of A into adjoint A will be what? Determinant of this thing. So it will be determinant of A whole cube. So that means first property that comes, this is determinant A, determinant of adjoint A is determinant A cube. So determinant of adjoint A is determinant of A whole square. Determinant of adjoint A is determinant of A whole square. Got it? Now on this particular property, one question we'll do directly. There is a question. If P 1 alpha 3 1 3 3 2 4 4 is the adjoint of a 3 by 3 matrix A, determinant of A is 4, then they are asking for the value of alpha. All right, I give you 2 minutes to solve it. I'm also launching a poll. There are options. Please solve it and give your answer. Yes. Yes, everyone, what is the value of alpha? Yes. Well, so many people answered. I think no one answered correctly. See, P is given to you is the adjoint of matrix A. All right. That means P is what? P is adjoint A. It's a 3 by 3 matrix. So determinant of P will be determinant of adjoint of A, and that is determinant of A square. Now determinant of A is given to you 4. So determinant of A square will be 16. That means what you have to do, that is determinant of P 1 alpha 3 1 3 3 2 4 4. This determinant value should be 16. Now I give you another 1 minute. Quickly solve the determinant and find the linear equation in alpha, get the value of alpha quickly. Very good. Kaushik, very good. Anybody else? Very good, JNV Kadapa. Suraj, very good. Very good, Kolhapur, JNV. Good. See, now most of you are getting right answer. You just expand this determinant. It is 1 time 12 minus 12 0 minus alpha times 4 minus 6 plus 3 times 4 minus 6. That should be 16. So 2 alpha minus 6 is 16. So 2 alpha is 22. So alpha is 11. Got it? Now come to theory point again. Now see, first relation that I got, that is A into adjoint of A is determinant of A into I3, that is also adjoint A into A. Got it? Now, second point we covered, determinant of adjoint A is determinant of A square. Determinant of adjoint A is determinant of A square. That is valid only if A is a 3 by 3 matrix. Third point. Now see, determinant of adjoint of A will be determinant of A raised to the power 4. I should even write a determinant of A raised to the power 2 raised to the power 2. Now, how did it come from? See, from this determinant of adjoint A is determinant of A square. Replace A by adjoint A. So left side will become adjoint of A is determinant of adjoint A square. And determinant of adjoint A, you just calculated determinant of A square whole to the power 2. Am I clear? And now from this property only, you can generalize that determinant of adjoint of adjoint of adjoint of adjoint of A. Say adjoint is repeating k times. So this is equals to determinant of A raised to the power 2 raised to the power k. Determinant of A raised to the power 2 raised to the power k it is. Now, got it? Another property. Adjoint of A transpose is adjoint A transpose. So you first take transpose, then you take adjoint, or you first take adjoint, then you take transpose. It does not make any difference. Got it? Now see, from the very first thing I have shown you that A into adjoint A is determinant of A into I3. If I take determinant of A to the left side, it will be A into adjoint A upon determinant of A is I3. That means product of these two matrices is what? Product of these two matrices is identity matrix. So this is what? This is the inverse of A. So A inverse is adjoint A upon determinant of A. From there we will see a property. We all know that A into A inverse will be identity matrix. If you take determinant both sides is 1. So that is determinant of A inverse is 1. So that means determinant of A inverse is determinant A to the power minus 1. That means 1 upon determinant of A. Got it? Now see, there is a very good question over this concept. A and B are two invertible. You just see it once. Check it, absorb it. Got it? Now, the question is, A and B are two invertible matrices of order 3. Determinant of A, B, A transpose is 8. All right. Determinant of A, B, A transpose is 8. This means what? Determinant of A, determinant of B, determinant of A transpose is 8. Now we all know that determinant of A transpose is determinant of A. So that means determinant of A squared, determinant of B is 8. Keep this relation. Now, determinant of AB inverse, that is determinant of AB inverse is 8. That is determinant of A, determinant of B inverse is 8. So determinant A upon determinant of B is 8. So determinant of A is 8 times determinant of B. Got it? Now they are asking for determinant of B A inverse B transpose. Now see, from this equation and this equation, you replace determinant of A by A determinant of B. So determinant of B cube will be 1 upon 8. So that means determinant of B is 1 by 2. You got it. If determinant of B is 1 by 2, then you replace it here. So determinant of A is 4. Right? You replace the determinant of B value here. Now the question they are asking, determinant of B A inverse B transpose. That is determinant of B 1 upon determinant of A, determinant of B. Determinant of B is 1 by 2. Determinant of A is 1 by 4. And determinant of B again 1 by 2. So your answer comes 1 upon 60. Very good question. Got it? Fine. Now we'll do this question. JEE 2019 shift 1 का question है ये. And I give you 2 minutes to solve it. Quickly start. Yes. Yes, quickly. Four people answered this question. One answered one answered two, one answered C option, one answered D option. Very good. Well, now let's start. Now see, definitely they are not expecting that you multiply all of these determinants. Got it? So there must be some pattern. Like if I multiply the first two, 1, 1, 0, 1, multiplied by 1, 2, 0, 1. Got it? What it will be? First row, first column 1. First row, second column 1 plus 2. First row, second row, first column 0. And second row, second column, answer is 1. Got it? Now we are multiplying it by 1, 3, 0, 1. Let us see what comes out. First row, first column 1. First row, second column. Got it? That will be 3 plus 2 plus 1. Now second row, first column 0. And finally, second row, second column, answer is 1. So do you realize a certain pattern is going on? Isn't it? If it is so, so up to 3, this place came 1 plus 2 plus 3. So up to n minus 1, this left side determinant will be 1, 0, 1. And here it will be 1 plus 2 plus 3 up to n minus 1. Now they are saying this is equals to 10178. That means 1 plus 2 plus 3 up to n minus 1 is what? 78. So this will be n minus 1 into n by 2 is 78. So if you make it, if you see it is n into n minus 1, 178 is 156, which is 12 into 13, I guess. So it's very much clear that this n has to be 13. Yes or no? N has to be 13 means they are asking for now inverse of the matrix 1, 0, 1, 13. That is what, if this is A, they are asking for A inverse. A inverse was what I just told you, adjoint A upon determinant of A. Determinant of A is 1 and adjoint can be directly found out in 2:2. Change the diagonal entries and change the sign of diagonal entries. Divided by determinant of A is going to be 1. So your answer is 1 minus 13, 0, 1. Got it? 1 minus 13, 0, 1. So B is the correct answer. B is the correct answer. Am I clear? Now, one thing I would also like to tell you in matrix, there are 4 important determinants which I think you should remember, which are being used very frequently. Got it? So it is like 4 important determinants. That is determinant 1a square, 1b square, and 1c square. This is equals to a minus b minus c minus a. If you see any determinant in this form, its value is a minus b minus c minus a. Now, if they are saying, say, a, b, c are the side length of a triangle, and then they say this determinant is getting 0. So what kind of triangle it is? So that means either a minus b is 0 or b minus c is 0 or c minus a is 0. That means either a equals to b or b equal to c or c equals to a. That means this triangle is at least isosceles. Or it can be equilateral, but isosceles too it has to be. Now second is 1a cube, 1b cube, and 1c cube. It will be a minus b minus c minus a, and then a plus b plus c. Got it? Then 1a square a cube, 1b square b cube, 1c square c cube. This will be a minus b minus c minus a, and ab plus bc plus ca. And finally, a last determinant, that is abc bca cab. This is minus of a cube plus b cube plus c cube minus 3abc. Got it? A cube plus b cube plus c cube minus 3abc. This can also be written as, with a negative sign, a plus b plus c, a square plus b square plus c square minus ab minus bc minus ca. which can also be written as minus of a plus b plus c into a minus b whole square plus b minus c whole square plus c minus a whole square whole divided by 2. Got it? Now say in equation they are asking you ABC are the sides of a triangle and this is 0. Now this is 0 means this is 0. And this is 0. See, a plus b plus c cannot be 0. This is 0 means this is 0. And if this is 0, that is possible only if a equals to b equals to c. So these are actually 4 important determinants which I wish if you can remember. That will be very useful and very frequently used in certain questions in every exam. All right. So today mainly that we covered is the system of linear equations using Cramer rule, where we see if it is a 3x3 equations, like equation in 3 variable, then for unique solution, D should be 0. For infinite solution, D 0 as well as D1. For unique solution, D should not be 0. For infinite solution, D0 as well as D1 equals to D2 equals to D3 0. And for no solution, D0 and at least one of D1, D2, D3 is non-zero. Then I have told you about the properties of how to find the adjoint of a matrix and then properties of adjoint. After covering, we have also seen in the meantime little bit about the inverse of a matrix. And once we have done that inverse of a matrix, then we started with after the inverse of a matrix, we did certain questions on inverse. Okay. I hope I have been able to add some values to your knowledge. Now just a call about this class feedback and then we will end this.